So on Tuesday we went over the structural testing, and we contrasted it with functional testing, where functional testing looked at the specification and see how much of what we had specified was actually implemented and was actually behaving as advertised, and based on certain criteria, based on edge cases or equivalence classes. Right, we focus on these edge cases because that's where we tend to make mistakes. Right, that we might misinterpret something, and we try to iterate one more time or one too little time, or we might misunderstand whether a particular value is included or is greater than or less than. And so those edge cases is what drove our initial selection of all the inputs that we consider on our unit tests. And without regard of the actually implemented code, right? We didn't really care whether it was implemented one way or another. So basically, that's why we refer to it as black box testing. We then contrasted functional testing with structural testing, where we do care about that the implemented algorithm, right? That once we executed the unit test, we start realizing that perhaps there might be portions of the code that never get executed, or some particular branch in an if statement that for some reason it never gets executed. So what's wrong? So looking at so there might be something wrong with the unit test, right? It's not causing the inputs that are being used are not causing our application to flow through certain pieces of code. So this gives an opportunity to challenge: do we even need this piece of code, right? Or even challenge the initial requirements that somehow were interpreted into the implementation of that piece of code. And so structural testing, forces us to look at the code and start looking whether, depending on the actual implementation, start to identify certain pieces of the branching or certain pieces of values of the input that would cause the flow of the application into certain areas of the application. And even one considering a particular branch, special values that we need to consider that would make our algorithm misbehave, right? So certainly looking at the implementation can give us an idea of whether our unit tests are inadequate, right? Or there might be certain things that we might need to think of additional unit tests to force the branching to certain areas, right? So last week we focused on creating a unit test where you wrote certain algorithms, and the unit tests are testing that implementation based in a purely black box implementation, right? Where you know that for a certain set of inputs, that the output has to be whatever, right? Based on whatever requirements I gave you from the previous assignment, okay? And you went off and implemented whatever looping and branching and that implemented that algorithm. This week we're gonna add structural analysis, right? We're going to see if those unit tests are covering your entire algorithm, right? Whether we like to be able to see if there are certain parts of the algorithm that never get executed, right? Are there parts that are not being tested? So we like to measure the statement coverage, the branching coverage, right? And see if you need additional unit tests to fix that. In addition to that, we're gonna in today's assignment that is gonna go out today, we're gonna run the same structural testing analysis on algorithms that you implemented last week in the last sprint. There's going to be lots of code in our assignment because of the technology stack that we chose that is not going to be covered, right? For instance, none of the controllers, right, and none of the the repository, or none of there's going to be a lot of code that our code coverage is going to report as not tested, right? That there's lots of lines of code that just never get executed by your unit tests, right? So we'd like to fix that as well. So today we'll introduce some new techniques that will allow us to not only exercise and validate algorithms that you worked on last week, but things such as controllers and whatnot, and we'll see some of the challenges that associated with that. For instance, testing controllers, it has a complexity that they need to be run inside of a server. They need to. They might have other dependencies and other network dependencies. The server has to be running. It has to have a web context. It might need to connect to a database. So the database needs to be running. Needs to have a repository actually talking to a database. Database connection. So we like to be able to, as much as possible in unit testing, isolate whatever code that we're testing, from any dependencies that there might be. So today we'll talk about techniques by which we can mock or create a virtual version of those dependencies so that we can isolate our code so that we can be tested independently as a unit. Okay?